Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so you should check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. Go to dataengineeringpodcast.com/Datadog today to start your free 14-day trial and get a sweet new t-shirt. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. Your host is Tobias Macy, and this week I attended the Open Data Science Conference in Boston, and I recorded a few brief interviews while I was there. First up, you'll hear from Alan Anders, the CTO of Applecart, about their challenges with getting Spark to scale for constructing an entity graph from multiple data sources. Next, I spoke with Stepan Pushkarev, the CEO, CTO, and co-founder of Hydrosphere.io, about the challenges of running machine learning models in production, and how his team tracks key metrics and samples production data to retrain and redeploy those models for better accuracy and more robust operation. So I'm here with Alan Anders, the CTO of Applecart. So could you just start by introducing yourself?
I'm Alan Anders, and I'm the CTO of Applecart.
Fair enough. So we were just talking a little bit, and you mentioned that your primary sort of data engineering concern is being able to process and create knowledge graphs at large scale by sourcing data from multiple different layers. And so I'm wondering if you can just talk a bit about some of the ways that you're sourcing that data and some of the challenges that you're working on overcoming.
Sure. I mean, I could say I come from an ad tech world where we used many servers and distributed computing in different ways. And when I came at Applecart, that's how it sort of was. I found that we did a lot of batch computing in strange ways, and I actually moved the entire company to Spark. And we actually we're big users of something called Databricks, which I'm sure you're familiar with. We have all of our data engineers and data scientists, utilizing Databricks and Spark with shared libraries through GitHub. And it's actually been very effective at building sort of these batch ETLs, but still being able to do this extensible object-oriented programming with many different moving parts, if that makes sense.
And as you're trying to create these entities from multiple different sources, are you having challenges with creating a unified representation of that data so it's easier to merge things together?
Absolutely. So the entity resolution problems are really tough. A lot of our data sets have, like the profile data sets, they have attributes of very many different kinds of flavors. And figuring out, maybe you have n profiles and you want to do n choose 2 matchings. It's a nightmare to try to handle this and handle it at scale. You're simultaneously trying to do sort of machine learning techniques to say profile A is the same thing as profile B across these 2 different data sources. At the same time, within each data set, you have to dedupe them, which is also sort of an entity resolution problem. And it's the bookkeeping can be a real nightmare in addition to the machine learning aspects and the at scale aspect. So if you're dealing with 2 data sets, 200 million profiles, 100 columns in each, how do you say these 2 are the same, and how do you process that data pretty quickly? That's sort of the challenges that we come up against.
And what are some of the ways that you identify the places to source data from and then actually build the connectors to be able to consume that data at appropriate levels of scale? And also particularly thinking about things like rate limiting from various sources, being able to make sure that things are flowing along at the proper rate from multiple sources to be able to merge them together.
That's a very interesting question. So there is a lot of sort of data analytics, data science analysis, and business analysis that goes into that. So, I mean, if you look at profile data, you have to ask yourself, how often does that data change and how often do I want to refresh it? So for things like demographic data, how often are people changing their ethnicity, their gender, their religion? Not very often, right? So if I have data sources that are fueling that, maybe I don't need to update that data. Now, last names change, addresses change. You think about 20% of the nation moves in a year, and you have to ask yourself, how often do I want that update change, and how often, like, how do I detect that online? And those things can be kind of tricky. For other data sets, like you're talking about, your more streaming ones with messaging, like Twitter, a lot of these problems have actually been solved. Data, I would say scraping is like CSE 101, and you have to be very choosy of where you invest in that. We try to invest in the kind of scraping that requires like an extra barrier, right? Or it's very specific to what we're interested in terms of building real world relationships. So I would say it's actually, the challenges are definitely sort of scale, but more often when you really ask the question of what you need, the scales come down a lot. And a lot of this like classical streaming technologies that we'd use like really fit the bill for us.
And do you find that you have any issues with the sources of data not being available when you're trying to consume them? And have you had to build in any extra engineering effort to manage fault tolerance when your sources are not able to produce data at the rates that you're trying to receive them?
Yeah, that definitely comes up. We definitely have pauses in our data streams. We're kind of a different beast, right? So we're trying to build machine learning probabilities of how people might, behave in certain situations. So we're trying to understand who's going to get off the couch to go vote. We want to build that probability in a campaign in real time. It's sort of very strange because these machine learning models and how they operate, like a lot of those data sources that we're talking about that are streaming in those regards, we're not necessarily going to incorporate into those models. And so a stoppage or if one of our collectors breaks, it ends up not being disastrous for our clients. So that ends up being okay, and we can invest those engineering efforts to fix that over longer periods. But it's something that we do think about a lot, as we scale. How are we going to fix that? Yeah.
And what have been some of the most challenging aspects of building and maintaining your data systems for being able to create these entities?
Spark. Spark is the real... the documentation for Spark is all over the place. I think you definitely have to have like an intuition for distributed computing. How does a join really work? What is skewing? Things like this. And we have people at different sorts of knowledge, different points of knowledge within in their growth with Spark, and distributing that information is very hard. So, I think they're getting better at sort of doing knowledge sharing at like the Spark summits and things like this, and we interact with the Spark contributors as much as we can, but it's an ongoing fight.
Before I go to the last question, are there any other aspects of your data platform or some of the challenges you're facing that you think we should cover?
Yeah. So what's very unusual about us is because we sort of are deploying a lot of our services from sort of a consulting perspective. When we work with campaigns or work with commercial clients, they're often not sophisticated enough to utilize the machine learning probabilities that we produce. So that gives us a lot of leeway in terms of not necessarily delivering immediately. On the other hand, we do have sort of the spike infrastructure where we need to spin up 100 nodes, 150 nodes, 250 nodes, and then shut them down. And a lot of the different vendors we work with, they're not used to this. They're sort of all at this constant, they want to charge us at so many nodes over a month, and then, you want to upgrade to 10 nodes, fine, this can cost this much. It doesn't work for us. We need sort of this spike infrastructure, spin up and spin down. A lot of databases don't work for us. We generally use a lot of cloud storage with Spark so that we can have that spin up and spin down. We've had to been very choosy about the kind of partnerships that we've been with. So there are companies like Data Robot that do machine learning but have those sort of, their business isn't ready for that spin up, spin down. And we're in like talks with companies like Datadog for instrumentation, and this is sort of new for them too. So we're trying to find databases that can handle that. Right now we're looking at something like Databricks Delta, which actually does allow for that sort of behavior. And we're sort of also trying to explore other technologies.
And as one last question, what do you see as being the biggest gap in the available tooling or technology for data management as it stands right now?
That is a really good question. Yeah, I mean, there are these little things that we find here and there that just aren't made for startups. And I kind of was mentioning this to you before we started talking is there's just certain Spark operations are not performant, especially certain kinds of machine learning computations. And it's the research is getting there in terms of like how do we scale graph computations, how do we scale certain machine learning or like principal component analysis, and they want to integrate that with Spark because everyone loves using Spark, if you're small or large, for doing these computations, but it just currently doesn't work. And so I'm really happy to see the open source community kind of like trying to solve this, but it's still way behind. And companies like Google and Facebook believe have these problems solved, but won't share it for the rest of us. So we don't have hundreds of data scientists or data engineers, solving these problems.
And for somebody who wants to find out what you guys are up to or follow along, what would be the best way for them to do that?
Oh, yeah, great. Yeah, very much. Visit applecart.co. Reach out. We're very much hiring. We're very interested in strong data engineers, strong data scientists. We have some product roles opening up. And, if you don't know, you don't have those backgrounds, we love smart people. Political scientists, mathematicians, physicists. We have sort of very many applications that we're looking for right now.
Well, thank you for your time. Enjoy the rest of the conference.
Thank you so much, Tobias.
So I'm here with Stepan from Hydrosphere.io. So could you just start by introducing yourself?
Hey, I'm Stepan. I'm from Hydrosphere.io. I'm founder and CTO. So I used to work as a software engineer for many years, and then I used to build and architect big-scale stream processing systems based on Apache Spark, Apache Kafka ecosystem. So, and also I used to work a lot with machine learning engineers and data scientists to make them happy, to make them successful in delivering their proof of concepts in notebook environments to the real end-to-end, real-time production applications.
And at Hydrosphere, you're working on sort of closing the loop of AI and machine learning models in production to make sure that they're doing what they're supposed to be doing. So don't know if you can just talk a bit about how you do that and some of the types of metrics that you use to be able to understand how well these things are running.
Yeah, well, so everybody is focused right now on training. It's very sexy, it's very hypey. We are taking one more step ahead, and we are automating serving and productionizing part of the machine learning. So we do model deployment, serving, and monitoring. Monitoring is the most crucial part because deployment is a boring thing, and monitoring of the model performance and the input features to the model and output predictions is the most crucial part. So what we do, how we do that? We monitor distributions of the input features. We apply different statistics like Kolmogorov-Smirnov correlations, clustering-based algorithms to we basically know about your production traffic as much as possible to be able to detect a concept drift and model degradation. And also we use these statistics to do resampling to generate a clean and diverse data set for your retraining pipeline. So we'll help you to maintain and retrain your models in production as you go along. Yeah, it's obvious. Obviously, your model is as good as your data. If your data is being changed in production, your model is not as good as it's supposed to be in a training time. So, and this like a very, very challenging part of the machine learning to maintain the model quality over time and to scale that. The question of scale is probably the next most important question in the industry. If you as a data scientist owning and building 10 models, 10 different models, and every model has 10 different versions, how would you watch them in production? It's not your day job to watch models and identify the model drift, concept drift, and model degradation. So obviously you need more tooling to augment your day-to-day operations. And this is here we are. We apply AI and machine learning to monitor your machine learning models in production. So this is basically the same concept that is being used in the history a lot. Machines help to build better machines better. Computers help to build better computer programs, and now AI can help to build more reliable and fault-tolerant machine learning models. So this is like the high-level overview.
And when you're monitoring these various metrics for the machine learning models, what are some of the things that you specifically look at for being able to identify that the output of a model isn't within the desired bounds? Is that something that you automatically detect once the model gets put into production, or is that something that needs to be predefined once the model gets pushed into your system?
So we can automatically profile your training data. So and build the basic data profile what you have. It might be statistical metrics. It might be deep auto encoders. Like it might be. So we're actively using GANs right now. Originally GANs are being used for fooling the predictor to make it output the wrong prediction, and we are probably the first who is using that to generate not a noise. We generate a drift. And we train our discriminator to identify a model drift. So it's it's one of the techniques we use, and we actually combine different methods and different metrics. So it might be like a simple statistics, it might be more advanced statistics, might be some ad hoc rules, and in addition to deep learning and anomaly detection methods. So if they are coincide all together, this is like a great sign for the model degradation. So it's there is no silver bullet for this. Every model is unique. And this is kind of a new discipline to look at for machine learning engineer. How would I make my models more reliable? What metrics should I use for my model to monitor? So this is. As I mentioned, there is no silver bullet. There are different methods, different metrics. There is some unified approaches, like just watching a distribution of input features. Okay, we can do that for almost any input except images and maybe words, NLP use cases. But for the classical machine learning, you can monitor the age, the wage, the salary, or whatever features you have, and yeah, that's. All the tooling is like in place for many years for that. So just a matter of like applying that and automating that. The crucial thing is why the traditional monitoring, like software monitoring methods, do not work here. Like there are a lot of system monitoring, CPU, GPU, because the metrics are much more complicated than just a simple counter or histograms. For example, Kolmogorov-Smirnov, it's a stateful metric. You need you need two samples to compare, and you need to do that in a window. So, and you need to do that in a real time. So we do that internally. Everything is based on Kafka streams. So we do that like a stateful aggregation and stateful calculations of these metrics in real time. So that's how we work.
You preempted the next question I was going to ask, so thanks for that. And in terms of the data that you're sampling for being able to retrain the models, are you keeping track of the data that's coming in and then the output that's going out to determine which inputs are producing valid outputs and which ones aren't, so that you can then determine which data points to sample for being able to retrain the model to bring it back in line with the expected outputs?
Yeah, for resampling, we do not watch for outputs. It's mostly for inputs. If you do have outliers in production, that's fine. You need to include these outliers into your training pipeline to make it more reliable. Because you at the end of the day, you will get these outliers in production, and you need to be ready. Your model need to be ready to do that. Yeah, and this is mostly an input monitoring the inputs of the model.
And what has been some of the most challenging aspects of building Hydrosphere and determining how best to scale it and architect it to be able to serve your clients appropriately?
Yeah, it's a wide question. It's an open question. So besides just technical challenges, of course, it's like all things Docker, microservices, and Kafka. Besides that, the challenging part is probably socializing the idea and the evangelism about that. So a big part of education of the clients and education of the community. And another kind of not a showstopper, but very challenging part is that we are a little bit ahead of the progress rather than comparing to the average in the industry. So everybody is building the models, yet trying to figure out how to build their training pipelines, figure out how to build their data pipelines. And when we offer something advanced, we need to help clients to do the basics. That's why we are kind of trying to focus just on our product and without like spreading our focus across the whole machine learning business and industry and machine learning development.
So you're trying to make people aware of the pain that they're going to be suffering before they actually get to that point, and because they haven't experienced it, they're having a hard time seeing where they might be able to use you.
Yeah, so before even building a sophisticated model, what we try to emphasize is, can you build a very naive model but can you build it overnight and deploy it into end-to-end application and get a feedback from business and get a feedback from the from users, whatever, and then improve it continuously. So that's so you can be in production after 1 week of research and development. This is kind of everybody can want to do that, but what we see, companies just hire data scientists. They spend a year prototyping in machine learning notebooks, and they don't have a single model in production. So this is a changing. Sometimes it requires to change an organizational structure to make data scientists more aware about the final goal and the final production. So it's very, very tough topic.
And do you think that that's why the whole idea of a machine learning engineer as a distinct role from data engineering and data scientists is starting to gain more prevalence?
Yeah, so we target machine learning engineers rather than data scientists. So if a machine learning engineer responsible for delivering a final value to production, to the end users, he's interested in closing that feedback loop and having leverages in his hands to drive that, to craft that. So and not to throw out of through the wall to IT people. Yeah, that's another like a cultural aspect of that. The traditional IT operations that do monitoring, they do support, and especially in big companies, they have no idea about machine learning. If we expose them a metric of Kolmogorov-Smirnov test, it means nothing for them. So, and they even don't know how to adapt and how to react on that alarms. So that's why we need a machine learning engineer to watch these metrics, to watch these alarms, and probably at least to be in the loop, because the serving pipeline, there are like 1,000 of reasons why machine learning may not work in production. Yeah, the data pipeline might be even broken. Your upstream application just started producing your corrupted input features. So it's like there is no a single tool to monitor that and to fix that. That's why it's like the whole team should be aware about any incidents in production. If your apps, it's actually another interesting use case that we are working right now. So if you're differentiating between expected failure and unexpected failure, expected concept drift and unexpected. So for example, if your upstream pipeline failed to produce your right features, this is unexpected drift. You should not retrain your models on these bad features, yeah? Because they will propagate through the training and serving pipelines to the end users. So you have to classify between that like kind of expected drift and unexpected system failure that you just started receiving like something different. So that's another interesting aspect of using AI or machine learning to help operationalize machine learning in production.
Yeah, I've been definitely seeing a lot of trends towards adopting some of the principles that the DevOps movement brought between developers and IT staff, moving into the realm of data engineering and data science and some of the more statistically oriented roles within a company.
Yeah, I hope so. This is where we are, and following that idea, everybody wanna be AI first company right now, and one of the major step towards AI first company is to improve that organizational processes and educate people about production, about end value, about iterations, about all that DevOps stuff that is like already in the past for most of the companies. But yeah, I still see that engineers just make that work on their laptops, and that's it.
And are there any other aspects of machine learning engineering or model serving or hydrosphere in general that you think we should talk about?
I don't know. Probably I covered almost everything that I have in my mind. Probably, yeah. The one I wanted to, as I mentioned, I don't have a word. I didn't coin any buzzword for the thing that we are focusing on, and probably one of the thought I have is like extension of AutoML, which is more, which is already like a little bit understood by the community. So you know how to, people at least understand and use it heavily. Automation around training process, about hyperparameter tuning, about model selection, and all that stuff. And if we can extend that to the production, so you will have serving, model monitoring, resampling, retraining in the same loop, that would be really beneficial for everybody.
Maybe we should just start having everybody call it prod ML, and then you can leverage that.
Prod AutoML as service.
So as one last question, what do you see as being the biggest gap in the tooling or technology that's available for people working with data management today?
Basically, actually there are a lot of gaps. So it's when you even start just experimenting, just having a Jupyter notebook up and running, just make your Spark application work perfectly with S3. It looks like a very, very basic thing, but when you start it from scratch, you can find a lot of like gaps. And if you're like data scientist, machine learning engineer, you just spend like tons of time on that. So that's one gap, and there are like perfect companies, amazing companies that are trying to build more tools for train. There is like weights and biases companies that just popped up, a new startup. Very cool. They do some tooling around training as well. So even training, it's very popular, and everybody's doing training. There are some playbooks, notebooks about that. You still fight with reproducibility of your experiments, about the versioning of your experiments. Even you have like a dozen of model versions. You just forgot about the. You could not track it properly. This versioning, their performance characteristics. Yeah, so some you name it. A lot of companies like do that. Data science collaboration tools, but I don't think it's perfect at this moment, and I don't think there are tools in open source to address all the issues in collaboration and training side. And of course, it's just a very wild area in a production side. So everybody is trying to invent a new wheel, and it's, if you will take a look at the slogans and of the companies and the tools, everybody say about like trying to use data ops. I have no idea what data ops is. So it's like 10 different interpretations and definitions of data ops, and everybody is production ready. But when you take a closer look, for some companies, production ready means having an ability to schedule a cron job. Okay, this is it a production? It's just an offline batch job. It's not a real production. So this like terminology and marketing hype is a little bit challenging to break through, So that's why I believe the podcasts that are really hardcore and that go straight to the point are very helpful to the community.
Great. Yeah, it's seems like the sort of data management, data engineering, and productionizing of some of these more advanced workflows is going through the same growing pains that the DevOps movement did, as far as not having a cohesive definition of what it even means to be doing that, and so it's open to interpretation and opportunism. So I think we're in those same growing pains stages, but I think that we'll come out the other side the better for it.
Yeah, definitely. We'll see more. So from the public use cases, you see. So we've been talking about some like theoretical stuff right now. So you see, for example, Taybot from Microsoft. You remember they launched that. So this is it's a public lesson for everybody how machine learning and AI in production might look like. When you do, even in Microsoft, even in their like pretty cool research environment, I believe they tested that Taybot on some Wikipedia-like data sets, and it worked pretty fine, pretty nice. But of course, the real world is much more tough than lab environment in Microsoft. So this is a result. So it's turned into racist, fascist, and all that. So it's not fun really. And actually, the question that is very like open question for everybody: was Microsoft able to monitor and adjust their models as they go along and prevent that unexpected shutdown of their bot? Did they have right tooling around that or not? So it was just a research experiment, but it might cost reputation of the company. It might cost like a huge efforts of the PR team to minimize the impact of the business. So and I believe like everybody can make their own assumptions about the impact of the ML failures in his project or in his business. So and like think through that. How can we improve the tooling and situation about that?
Well, thank you very much for taking the time, and for anybody who wants to see the work that you're up to, what would be the best way for them to find you?
So Hydrosphere.io, and follow the links, follow the social media. So I'm pretty open for any comments, questions, and thoughts and contributions. We have open source version.
Great, thank you very much.
Thank you.